Welcome to our lecture on histograms in Python. The libraries you'll need for this lecture are pandas for handling the data, matplotlib and seaborn for visualization. SNS is set as the default style. And we begin by loading the data set. For this lecture, our data reveals information about California real estate properties. It's located in the histogram data CSV file, which you can download from the resources with this lecture. Let's load it onto a new variable, real estate, using the pandas method readCSV. All right, to make sure everything is in order, we may like to check what our real estate table contains. Here, we've got information on the building and property type, as well as the listing's area and price. For our histogram, we only require one of these columns, which is price. With that in mind, we're ready to proceed with creating our histogram. To plot a histogram, we need the plt.hist function, and in brackets, we refer to our real estate price column. After adding plt.show, we're ready to run the cell. Great. The result is a histogram showing the distribution of the price column. The histogram has a total number of bins equal to 10, which is the default built-in for this histogram function. But is that number optimal? Choosing the appropriate number of bins, or the bin size, is the most crucial element of every histogram. Through varying bin sizes, a histogram can reveal vastly different insights. Lucky for us, we're allowed to alter the number of bins with the help of an extra parameter. Matter of fact, if we type in plthist and press Shift and Tab, we can explore all available parameters for a histogram. X is the variable to be plotted. In our case, that's price. Next comes the bins parameter. Here, we can handpick the number of bins we'd like in our histogram. Great! The third parameter is range, through which we can specify the range of a histogram. Here, instead of the natural domain of price, we could narrow it down to a smaller interval. The Boolean density parameter allows us to specify the representation of the y-axis. If true, the counts are normalized to form a density distribution. Cool. Now let's get busy with some formatting. For this histogram, we will utilize the bins parameter and set it to 8, while leaving you to explore additional options on your own. Excellent. Let's increase our chart by creating an 8x6 figure. Also, let's alter the bin's color by adding a color argument. For our histogram, it will be the close to our heart's blue color. It's the 365 Data Science Blue, which has the code number 108A99. Excellent. And of course, we haven't forgotten about a title. It reads, Distribution of Real Estate Prices. To really set the title apart, let's select a font size of 14 and also set it in bold. Speaking of proper labeling, we shouldn't forget the axis labels. With pltx label, we set the x-axis label to price in 1,000 of dollars. And for the y label, the name is number of properties. It's time to examine the result. Superb! The next step is to change the background of our chart. For a histogram, we'd prefer a more clean design rather than the default gray background. First, we switch to a white background with the SNS setStyle function. Apart from white, here you're free to select white grid or dark style among others. Now let's use SNSD-spine to remove the top and right borders of our chart. If you like, you can specifically remove a grid with left, right, bottom, or top, and equal to true. And the result is marvelous. As sleek a histogram as any.